To test any hypothesis in quantitative research, you have to measure your variables. Without measurement, there are no answers. Measurement is the specific act of assigning numbers or symbols to characteristics according to a pre-specified set of rules. But there is a strict rule. You cannot measure an object itself. You can only measure its discrete properties. With physical objects, this is straightforward. We measure length and weight. But human beings introduce abstract, subjective attributes, things like organizational commitment or price consciousness. These internal human states do not come with physical yardsticks. A researcher cannot wrap a measuring tape around an employee's loyalty. To extract rigorous numerical data from invisible human forces, we have to engineer a structural bridge. We have to make the unmeasurable measurable. This engineering process is called operationalization. We bypass the abstraction entirely. If we cannot see the internal state itself, we measure the reliable, physical behaviors that state produces in the real world. Take the concept of thirst. Thirst is invisible, but we can operationalize it simply by measuring the exact number of fluid ounces a person consumes to quench it. Corporate variables require much more heavy lifting. Constructs like workforce diversity or managerial expertise are deeply complex and cannot be captured with a single metric. Scientific rigor requires us to strip away subjective guesswork and translate those sweeping concepts into a strict, observable behavioral index. This diagram shows our starting point, a single central concept. We'll operationalize a complex variable, achievement motivation. You cannot simply ask a subject, "How motivated are you?" The term means different things to different people. The resulting data would be useless. So we execute the first layer of reduction. We break this central concept down into broad behavioral categories called dimensions. Our central node branches into 5 distinct dimensions. Dimension 1, the subject is driven by work. Dimension 2, they are unable to relax. Dimension 3, they are impatient with ineffectiveness. Dimension 4, they deliberately seek moderate challenges. And Dimension 5, they actively seek frequent feedback. We have successfully mapped the structural boundaries of achievement motivation, but these 5 dimensions still exist as abstract concepts. They cannot be counted. This diagram shows the final phase of operationalization, breaking dimensions down into elements, the actual, observable behavior patterns. Under the first dimension, driven by work, we isolate our first element, constantly working. We quantify this by tracking the exact number of hours worked per week. The second element is persevering despite setbacks. We measure this by logging the specific number of failures a subject endures on a task before giving up. The third element is reluctance to take time off. We quantify this by tracking the frequency of absence days. By isolating these distinct actions, we place human behavior on a verifiable mathematical continuum. We can separate those who score low from those who score high, based entirely on data. But there is a logistical problem here. Actually standing in an office with a stopwatch and counting these behaviors in real time is impossibly labor-intensive. The purpose of reducing dimensions into elements is to create a structure where researchers can safely swap their own subjective observations for a rigid count of verifiable actions reported by the subjects themselves.
This web shows the entire domain universe of achievement motivation. We must map every dimension and element to avoid critical blind spots. If we use too few elements, the scale fails to represent the whole concept. Missing behavioral facets results in invalid measure. Variables take different shapes. Aggression is a multidimensional construct. It requires separate items to measure verbal aggression, like shouting, and physical aggression, like throwing objects. This document shows an academic measurement scale, developed by Cacioppo and Petty to capture the need for cognition, the tendency to enjoy thinking. Even though need for cognition is a unidimensional construct, their validated measure required generating a pool of 34 distinct survey items. That volume was necessary to guarantee complete coverage of the concept's single domain. A valid measurement scale represents every dimension of the target construct. If there are structural gaps in the instrument, the resulting data is compromised. This diagram highlights the single biggest analytical error in measurement design, confounding a core concept with its correlates. Correlates are the antecedents or consequences of a variable. They are not the internal properties of the variable itself. Success is an external outcome. A highly motivated person is likely to achieve success, but success is not a dimension of motivation. A subject can possess massive achievement motivation, yet still fail at their job because of external variables entirely beyond their control, like a market crash or poor management. If a researcher uses performance as the yardstick for motivation, they have accidentally measured the wrong concept. Operationalization requires strict negative constraints. A valid definition aggressively excludes the reasons for a behavior and the consequences of a behavior.
Measuring byproducts instead of the core construct pollutes the dataset. It voids the scientific validity of the entire study. This diagram shows how abstract elements physically manifest in the real world. They detach, forming a grid of survey questions. Instead of observing secretly, we ask directly. Unable to relax translates to, how often do you think of work, mapped on a numerical scale. This requires one final component in the measurement pipeline, the judge. Someone must assess the quality or quantity of the attribute. Often, the object and the judge are the same entity. When measuring an internal state like shopping enjoyment, consumers evaluate themselves via a self-administered questionnaire. But you cannot ask a student to evaluate their own communication skills, or a brand of yogurt to evaluate its own taste. These require an external judge with specific domain expertise. This is the complete pipeline. We traverse from an invisible abstraction down to classified dimensions into observable elements and terminate in a functional mathematical scale. Before building this complex architecture from scratch, researchers consult the academic literature. Leveraging an existing validated measurement scale is mathematically safer, saves time, and allows your work to be directly compared to prior studies. Disciplined operationalization is the essential engineering process. It's the only way to transform invisible, subjective human realities into rigorous, replicable scientific truth.